Welcome everyone to today's webinar hosted by AHHikeGPS. My name is Brian Soliday and I have the pleasure to serve as Senior Vice President of Sales here at AHHikeGPS. We're going to cover a lot of information today. First off, we'll cover who is AHHikeGPS as a company. Then we'll talk about AHHikeGPS, the device itself, and the software tools that drive the AHHikeGPS workflow. I'll share with you some of the users of our technology. 10 years ago, our founder, Leon Turenberg, was collecting remote measurements of radio sites in Africa. Leon conceived of a way to integrate the various tools he was using out in the field into a single, simple-to-use handheld device. In 2004, the first prototype of the AHHike, which stands for I Know Everything, was developed. That idea was embraced by the U.S. Army Corps of Engineers, who provided creative funds to integrate the AHHike into their data capture program, with approximately 700 early AHHikes deployed across the Corps. We've expanded considerably from these early successes with significant growth across the commercial sector in a wide variety of market segments. Today, AHHikeGPS is headquartered in Wellington, New Zealand, with sales and support operations in Washington, D.C., Denver, Atlanta, and Raleigh in the U.S., and Liverpool in the UK, serving our customers across Europe, the Middle East, and Africa. Our customers are interested in using GPS to locate objects and assets. However, the real value they obtain from the AHHike devices and associated software is the ability to remotely measure objects. So as we talk through this presentation today, I ask you to think about what it is that you measure on a regular basis. In addition to remotely measuring assets, I also ask you to think about the why of collecting the asset location and the ancillary attribute data that you collect. What processes do you support? What other components of your organization can leverage this data across a wide variety of issues? Let's think about an asset such as a utility pole and the ecosystem of organizations that interface with that piece of real estate. In this scenario, the asset is owned by the local municipal power and light company that has their electrical distribution assets attached to this pole. There are a number of other utility providers that lease or purchase attachment rights on this real estate: fiber providers, landline telephone companies, cable, DSL providers. The power light company also has their street light attached to it. And then these utility organizations many times rely upon AEC firms to perform analysis and data collection on or about these poles. This content is used in a wide variety of inventory, regulation, compliance, and design processes. Organizations involved in vegetation assessment are also within this ecosystem to help in monitoring possible vegetation encroachment on the lines. Additionally, within the same image, there are other assets that can be accurately measured and mapped. So you can see there's a significant value across many potential users just by one particular data collection. The previous model of performing remote measurements of assets in the field centered around outfitting personnel with a variety of tools to capture and document the data. From a GPS to a laser rangefinder, digital camera, maybe a Hastings hot stick, even a pad and pencil. Not only is this cumbersome for the user out in the field, but tying all the collected data back together, transcribing notes once back in the office, is ripe for errors. The AHHikeGPS provides all these tools in a single integrated handheld remote measurement device. So let's talk about the AHHike. What is it? It's a remote measurement mobile device that integrates GPS with a laser rangefinder, 5-megapixel digital camera, compass, ruggedized mobile computer, and our AHHike tools and AHHike solution software. However, the key here is not the individual components, but the integration of all these technologies in a single, easy-to-use device. This integrated approach supports our users in performing remote measurements so they can do things such as measure line sag across a busy street, collect multiple targets from one single position, measure objects in restricted areas, collect calibrated imagery and measure off of that imagery, measure about any object or asset that they want, and they always have an image of each collection to verify exactly what was collected in the field. We have users telling us all the time that's very, very powerful for them. Let's briefly discuss the AHHikeGPS workflow, and I'm going to talk about this multiple times today, the AHHikeGPS workflow. The first step in the process is the use of the AHHike desktop software to easily create user-definable forms, all based on your field team's existing or proposed workflow. So you build these workflow using Ike Desktop's drag and drop forms builder to create the forms based on the available Ike tools and Ike solutions available to you. You then deploy the forms to the Ike devices. The field users then take the Ike devices and they perform remote measurement and standardized data collection driven by the forms and workflows created on the desktop. Once the data is captured, it's back into the office. If you're performing tasks such as measuring joint use attachments off the calibrated imagery you collected, then you use our Ike Annotate software, which is a component of the Ike Desktop. Otherwise, you'll use the Ike Desktop interface to import the data into a wide variety of formats for ingest into your favorite analysis or GIS mapping application. The workflow we discussed was from office to the field, back to the office. However, to really understand the creation of the forms, you need to understand the tools available to the field user to perform these tasks. So let's start with a review of the Ike tools and Ike solutions. Ike tools is a family of remote measurement functions that are licensed to the Ike device. With these core tools I'm showing you here, the field user can collect a wide variety of measurements and photos. Let's start with target position. So the target position tool allows the user to collect the location of a remote asset along with the location of the device at the time of the collection. So where I'm at and the object I'm collecting with only one click on the device interface. Additional standard data that is automatically collected with most Ike tools functions: distance to the asset, image of the target, bearing, date and time of collection, label, comments, a number of things. All data is then available for further analysis in the Ike Desktop application. So let's say I need to measure the location of these oil gas storage facilities. Difficult access. Here's the problem. The property is restricted. No trespassing. So I can either make a call to the property owner and schedule a time to get access to it and maybe end up waiting and burning man hours, or I can remotely measure the asset location. In this case, over 1,000 feet away. You'll notice the Ike device, on the Ike device I have a zoom capability as well, so I can actually zoom in using that 5 megapixel camera. I then use the form created in Ike Desktop to enter in any additional attribute information about that object. And then easily review the collection once back in the office. In this case, in Google Earth via the standard KML file that's easily generated via Ike Desktop. More on that process later. We'll get into that a little bit later. So if I select the icon of the target asset location on the screen there, that little icon, I'm then provided with a view of the image that was captured using target position, as well as the standard measurement information and the unique attributes collected using the process in the forms process. The 3-shot height tool allows users to measure the height of an object when they don't have a clear visibility to the object's base. The Ike user merely uses the ground and nearby and similar base level location to perform this function. Let's walk through the process as if we were in the field using the Ike. These are actually screen grabs from a data collection I did here in Colorado. From my Ike Tools menu, I select 3-shot height. The first step is to aim at the ground and select the green arrow. So I do that. It measures that point. The interface then tells me to aim at the vertical. Now notice how the AHHikeGPS interface guides the user within each step. So in the upper left of the Ike display is a graphic of what I'm supposed to do next, telling me aim at the vertical, as well as a text description next to it saying aim at the vertical. Also notice it provides to the object I'm collecting. In this case, 341 feet 6 inches. It also gives me the compass bearing from where I'm at to the location, the object I'm collecting. Once I collect that, it then tells me to aim at the top of the object and again select the green arrow. The height of the object is then displayed on the Ike device, and then like any other collection, back in the office I have access to the image with the collection height displayed on the image and the measurement and attribute data collected in the process. Collecting a span height has been a long-standing standard process in the utility space. In most cases, a two-man team uses a Hastings stick or a similar device to tap the line and measure that span height. If the low point of the span is in the middle of a roadway, this actually can be one of the most dangerous measurements for field teams to make. Using the span height function in Ike Tools significantly reduces the risk to your staff. That's a plus. as the user can stand across the street, away from the dangerous traffic, out of the right-of-way, and measure the span. Again, the user selects that specific function, span height, from the AHHIKE Tools menu on the device. They then proceed to aim and measure the wire they want to generate a span height for. In this case here, you can see that I've actually, on the right-hand side of that display, you can see a zoom feature, right? So I actually can, on the device, zoom in so I get a better view and make sure I'm hitting the line that I really want to hit. Once I collect that, the system, again, prompts me to aim at the ground. Again, the system kind of walks the end user in the field through the process. So it wants me to aim at the ground directly below the wire. So if you notice the yellow arrows on the AHHIKE display, using the laser and the integrated compass in the AHHIKE device, the AHHIKE directs the user to point the device to a point directly below the wire. So in this case, it's prompting the user to move the aim to the right and closer to the user. So if you notice on the screen there, the distance says 107 feet 4 inches, whereas the wire distance was 67 feet. So obviously, I'm hitting an object well beyond below the wire. So I have the AHHIKE aim beyond that. I adjust it, collect the point. Then on the AHHIKE, I'm presented with a photographic image and the measurement. Again, all available for viewing analysis back on the desktop as well. Our users also have requirements for measuring between 2 points. The missing line tool supports the user in collecting measurements such as the distance between 2 utility poles. Not only is this true distance measured, but because of the integrated compass, the horizontal distance is also provided. Additionally, many users in the pole auditing market have found significant value in automatically obtaining the bearing between those objects for further understanding of wire attachment angles at each pole, a true value add. In this scenario, the user wants to measure the distance of a drop from a pole to a residential structure. The user selects missing line, then is prompted to select the starting point, in this case the attached point on the utility pole. They then select the end point on the home and are provided with the captured image and the missing line distance displayed on the AHHIKE. The same image can be used for verification purposes to make sure when I get back in the office, did the field personnel collect the data that I wanted. You can also use this as a deliverable. Hand this off to a contractor that is tasked with actually handling the install. Sometimes our users just want to collect an ancillary photo of an object. In this case, the photo-only function in the AHHIKE tools is the answer they're looking for. Like target position, photo-only is a one-click process. So a user finds the photo-only function useful for capturing images like a pole's birthmark or maybe nearby signage. Again, the same interface. I can zoom in if I want, keep it like I have right there. I can also add labels. In this case, I'm going to identify the well, and then a comment for that, out of production. Okay? And then, if I want to, I can have a wide variety of attribute fields, should I desire. So really, it's up to me what I want to put in the form to collect when I'm out in the field. We recently added the vegetation assessment function to the AHHIKE Tools family. This had previously been a separate product, but now it's a standard offering in the AHHIKE Tools environment. It's worth about, from what we were charging before, this value add into the standard product now adds about an additional $4,000 in value. So, by selecting vegetation assessment on the screen, I'm then provided with a rich suite of measurement tools for vegetation. The first step is to obtain the height of the tree. So I aim at the ground at the base of the tree, collect that. I'm then prompted to capture the breast height, with the AHHIKE user interface again guiding me to correct the correct height, because it knows the distance and the angle given the compass. So it uses this integrated laser and compass combination to help guide me to collect that diameter of breast height. Third step in the collection is the top of the tree. Automatically, the user is then prompted to collect the tree crown width by selecting the far left foliage of the tree. I collect that. Then the same for the right side. The width is then captured. Pretty simple process. Finally, the user is presented with a zoomed-in view of the breast height location to measure the diameter of breast height, or DBH. Within the Ike user interface, the user is provided with a set of digital calipers, okay? And you adjust these calipers. It's almost like the calipers an arborist would use to go out and actually determine DVH, right? You use this, you interactively define the width of the trunk, and then provide it with an image of the tree with the height, the width, and the DVH on the screen. For viewing on the desktop, so once they're provided with an image, they can also view that on the desktop or in the application of their choice. In this case, like in Google Earth. And again, all the data is associated with the distance, the crown height, the width, the DVH, everything. For loading into a true utility vegetation management system. We've now covered the fundamental functions within the Ike tool suite. Now, let's move on to the Ike Solutions family of specialized field data capture solutions, Ike Solutions Polls and Ike Solutions PLS. Like the Ike tools, these software functions are licensed at the Ike device level. For users of the Ike Solutions Polls product in the field, the Ike device provides the user access to a function we call True Size Polls. This gives the users the ability to perform a one-shot capture of a calibrated image that will allow multiple precise measurements on that image when the image is accessed via the Ike Annotate function on the desktop. The Ike Solutions PLS product has the same true size functionality as Polls, but it's called True Size PLS. However, this tool is optimized to create measurement for direct import into the PLS Polls product. So our strategic partner, Powerline Systems, worked closely with us in creating this capability for their PLS Poll product. PLS Poll is a product that's focused on the analysis and design of structures, primarily poles and masts. Some of you online today may actually be users of this technology. To use either True Size Polls or True Size PLS, the user simply selects the function from the Ike user interface. The calibrated image that is collected has a crosshair embossed on the image so the user knows exactly what they were hitting with the laser at the time of that calibrated image collection. Again, great for validation. That was a comprehensive view of the full suite of remote measurement tools available to the field user. So now let's take a step back. Now that we understand what I have available in our toolbox for the field capture, and talk about building the forms and workflow for the field users. As we talked about earlier, the first step in the AHHikeGPS workflow process is the creation of user-definable forms using Ike Desktop. So let's focus on that. The best way to do that is via demo. This is the Ike Desktop user interface. First step that I do is just change my form name. So I'm going to say it's Denver Aslan. I'm in Denver collecting for a company named Aslan. Okay? Pretty simple process to actually build the form. So this is our forms builder, and it's a drag and drop interface. So what I want to do is just grab a number of functions on the left-hand side here. These are my Ike tools, and drag them over into the form. So I want to take a calibrated image, my true size form. I want to do a missing line, point to point. I want to also do a photo only. I also then have access to attribute fields to add those in. So in this case, I want to create a list. I want to do a simple yes, no. I want to do numeric. Maybe I want to add audio. Okay? Now, I basically have the fundamentals of my form built right there. Okay? The form's already built. But I really want to make it unique to my users so when they go out in the field, they truly understand what I want them to collect. So the way to do this is just do some editing. So the title that's going to display to them is True Size Polls, but I'm going to call it Poll Image. Okay, and that's going to be a mandatory field. So when they open this up, the first thing they're going to have to do is take a picture of that poll. It's that simple. Missing line. Well, the missing line, I want to change that because really what I want them to do is do a guide attachment. Okay, so now they know that it's, although it's using the missing line function, they know they're going to measure the attachment, the guide attachment. Now this can be a mandatory field, but a lot of polls don't have guides, so I'm not going to make it mandatory. I then have access to a number of functions or a number of output values that I can save. Actually, in this case, for missing line, there's 41 different values that I can save. So it could be, I just have the default here, but maybe I want to go and capture that missing line horizontal distance. So even though I'm capturing the guy from the pole to the anchor, given I'm collecting missing line distance, I now have the distance from my anchor to the pole along the ground. So I know how far it is on the ground as well. Okay. Very simple to do that. Okay. Photo only. My photo only is going to be called pole birthmark. I want to capture that pole birthmark, and that's going to be a mandatory. So I'm just going to capture an image using my photo only of the pole birthmark of the pole that I just collected. Okay. List. I want to know my pole type. Okay. And each time I collect a pole, I want to make that mandatory because I want to know what type of pole it is. In my items, this is just a listing of the type of poles. So I just type in wood, cement, steel, composite, and that becomes my list. That'll be my pick list that'll be provided automatically to my user in the field. Okay. Now that is mandatory, and because when my field teams are out, they tend to get in lines of like poles. So they'll get into a line where they're doing all wood, all cement, etc. So I'll say same as last time. So that means that after they do that initial collect, it'll automatically default to that value, so they won't have to go down through the pick list. It'll automatically default. They just hit the button and move on to the next. Again, speeding them up, increasing productivity. The yes/no function. This is going to be a field that I'm going to call damaged. All right, and that's going to be mandatory. By default value is going to be no, because it tends not to be a damaged. And then again, same as last time. So again, you can see I'm building these forms, although I'm creating it so that it'll increase their productivity and their amount of interaction will be reduced. And then numeric. So the numeric field is just going to be pole ID, and I'm going to make that mandatory, and since it's unique, I will not make it the same as last time. Okay? And audio is just going to be, I'm going to leave it as audio because they just know it'll be an audio note if they need to use the Ike device to capture some unique information about the pole. Okay? All right. Now the form's ready to be deployed to my Ike. I simply attach the Ike to my computer via the supplied USB cable and then select this button here, Deploy Form. It's that simple. Click on the button, it deploys the form to the Ike. Now my team goes out into the field and they perform an initial collection. But then they come back in the office with a few complaints about the forms I built for them. And a lot of it has to do around the workflow. They're saying, it just doesn't flow the way we're collecting it. We want to make some changes. Let me show you how you can do that. It's pretty simple. So they said after they do the pole image, they really want to grab pole type next. So I just drag it up and realign it. Then they said pole ID after that. Then it's easier to do damage, the pole birthmark, and then the guy attachment and the audio. So I can easily, just by dragging and dropping, realign the way that the form will be presented to them on the Ike device in the field. Now, during the Denver Collect for Aslan, they said, you know what, we ran into a number of fiberglass poles. So all I have to do is say fiberglass. Add that to the list. It'll now be presented to them. Attach my Ike with the USB, deploy the form. Now it's ready to go. So that's an easy way to create the forms in this really simple drag and drop interface. We have now addressed how we create the forms in Ike Desktop and deploy them to the Ike device. Then take the device to the field and perform remote measurement and collection via Ike Tools and Ike Solutions. The next step is back in the office, importing the data with Ike Desktop, measuring on calibrated images with Ike Annotate, and then exporting to your back-end systems and applications. The best way to show Ike Annotate is demonstrating the application in real time. So let's do that. The first step in the process is to load an image. So this is an image that I collected using the TrueSize Polls function, that single-click function in Ike Tools. Okay. Now you can see here on the middle of the poll, is that basically that embedded crosshair that shows me exactly where I was pointing when I collected this image. Okay, so again, this is a calibrated image that I can now measure off of. I want to give it a label, and this one, let's say it's off of that same collect, so I'm going to call it Denver Oslo. Okay, and any comments, I'll just say Ferry Road. Okay. Measurement type, I'm doing a pole audit. I can just validate that it is a wood and the condition is good. Okay. Now, on the image, you can see up here, again, you know, there's a lot of guidance provided by the tools that we provide. So here in AHHikeAnnotate, it tells me right-click the base, left-click attachments. So I go down to the base. So the user interface on AHHikeAnnotate is here telling me to right-click the base, left-click attachments. So I right-click my base. You can see it automatically provides me a zoomed-in view here. So I can use my caret keys, my up and down arrows, to actually align that for the correct base elevation. I accept that. Then I click here and say I want to measure the top of the pole. So I click there to the top. All right. Then I can collect other sorts of items. So I can say AC distribution, and this is my AC distribution. I can then do cable TV, and maybe this is my cable TV location, and adjust that accordingly again. Fiber optic, maybe the fiber optic is coming in right there. Again, attach that. Telephone, this could be my telephone line right there. Again, adjust that. Transformer, go to the top of the attachment of the transformer right there. And then things like guy wires. In this case, I only have a single guy. I'll click it there. There's the location. Okay, it's that simple. So it allows me to collect a number of items displayed on the screen here. Then all I have to do is save my markup. Now, it could be that my customer wants it in meters, not feet. All I have to do is select that, and it readjusts and recalcs on the fly. In this case, my customer wants feet, not meters. And then, if I know that I'm done, save markup. It then creates this image with all the text burnt in, and then also provides a data file that then I can use like a CSV file for providing that for import into some pole loading software or other sorts of applications on the back end. So a pretty simple process. So you can see that the AHHikeAnnotate has a really easy to use user interface that helps guide the user to collect the joint use attachments. Annotate PLS product is another component of the AHHike desktop. The images collected via the TrueSize PLS tool on the AHHike device are used in this process. As you can see, the AHHikeAnnotate PLS product has a different user interface, focused on the skill set of the PLS pole user community. The user makes simple measurements on the image and adds design components to the image. The user can first place a design element, such as a cross arm, onto the image. The AHHikeAnnotate interface provides the standard PLS pole libraries to help the user build the model via simple pull-down menus. In this case, the user can adjust the angle of the cross arm to match the image. And also build the pole model using multiple images of the same pole collected from different angles with the TrueSize PLS process. By selecting the PLS pole icon on the user interface, the system automatically builds the PLS pole model, such as here, and then places that model inside of that TrueSize PLS image. If the user has collected multiple images of the pole using TrueSize PLS, they can then do a virtual walk around of the pole, just built via PLS pole's modeling capability. I'll show you really quick. Same pole. There are a lot of additional great tools available within the PLS pole product. Too many to cover here. However, if you have additional requests for information regarding the PLS pole product, please reach out to us and we can put you in contact with our friends at Powerline Systems. Once users have completed the remote measurement and data capture process, whether via AHHike Tools, AHHike Solutions, or the AHHikeAnnotate process, the next step is to import a format for use in your back-end systems. The import function in Ike Desktop is very simple. As a default, Ike Desktop will import all your data into KML, CSV, XML, and a GeoMark format. Just connect the Ike to your computer via the supplied USB cable, open Ike Desktop like I have here, select the import function. It's that simple. Now, if I don't want to create all 4 of those outputs out of the data, I just open up Settings, as you can see here, click on the radio buttons, and select the ones that I want to create. By default, it'll create all 4, but if you don't want them, you can easily adjust. Because of the standard file formats used, the data can then be ingested by a wide variety of applications such as PLS, SpiderCalc, GE Small World, AHHikeGPS, and Autodesk products. One very important item about the licensing of the Ike software that requires mention. The Ike tools and the field components of the Ike Solutions polls and PLS are licensed to a particular device. In this case, you can see to the device, the true size polls and PLS, as well as all the Ike tools functions. However, the desktop software component has as many desktops as you desire. It is not a one-to-one relationship. However, you can have the desktop software running on 16 different desktops in 5 different offices across the country. So again, it's a really nice way to leverage the Ike device in the field and then have multiple people be able to actually do that joint use attachment survey on the desktop. Feel free to go to the support page on our website and download and try Ike Desktop, Ike Annotate Polls, or Ike Annotate PLS. It's free. So you can download the products here. We also have sample data, so you can try some of the annotation like I showed you earlier and see if it works in your environment. That covers the AHHikeGPS technology suite. We showed you how to easily create forms and deploy them to the Ike. The tools available in the field for remote measurement and attribute data capture were also presented. And then we demonstrated how to import from the Ike device and utilize the calibrated imagery to perform measurements such as for joint use attachment surveys. Finally, we discussed how to share this rich content across your enterprise with users of other ancillary applications. Now that you've seen the products, you're probably asking yourself, who's already embraced that technology and is using it to increase their field force productivity? There's a wide variety of customers that we have across the Americas here. These are not only utility companies themselves, but also the service providers to the utility companies that help go out and do their field surveys, do their joint use attachment surveys. Pretty broad group across the country. We also have a large number of international users throughout Europe and Asia Pacific that have embraced the technology and are using the AHHikeGPS solution in their daily workflow. I'd like to share one case study with you from one of our partners and customers, Hinkles & McCoy. H&M is well known for the critical infrastructure services that they provide across various markets. They selected AHHikeGPS for the ability for their field staff to rapidly and accurately collect not only measurements, but also photo verifiable records for their joint use attachment surveys. The digital nature of the Ike device reduced the errors they'd be getting because of transcription. Not only was this specific project completed 16 weeks faster than planned, but staff productivity increased from 20 polls per day to 45 polls per day, 125% increase in productivity. That's money to your bottom line and a smile on your CFO's face. Let's talk the AHHikeGPS devices. Here's a breakdown of the solutions we offer. You see the Ike Pro, Ike Solutions Polls, and Ike Solutions PLS. You can see within the Ike Pro product line, you get the device, 1-year hardware warranty as well as software maintenance bundled for that first year, all the Ike tools that I showed you today, the Ike desktop software that allows you to create the forms, the drag and drop forms, as well as the imported data off the Ike device, all the accessories, hard case, soft case charges, as well as GPS plus software, which enhances the accuracy of the GPS signal. So that's really the baseline unit. Ike Solution Polls is based on that Ike Pro. What we then do is provide a low magnetic signature tripod, and then the true size polls, which is again licensed to the device, and then the Ike Annotate polls, which is available on the desktop. The Ike Solutions PLS for users of Powerline Systems PLS poll product has all the functionality and all the tools available in the Ike Solutions polls, with the addition of the true size PLS, again licensed to the device, and then the Ike Annotate PLS which is part of our desktop. Thank you for taking the time to view and participate in this webinar. We've covered a lot of material to help you in understanding the value of the AHHikeGPS technologies in the workflow. Please take the time to visit our website for access to some additional technical information, including white papers, case studies, as well as additional videos. We'll think you'll find these helpful. Also, please feel free to reach out to us via the contact information displayed to request a more in-depth demonstration of our suite of offerings, as well as requests for a formal price quote. AHHikeGPS, measuring everything faster.